Hello guys, welcome to this video lecture. In this lesson, we are going to explore one of the most important concepts in how machines learn, a concept rooted in linear algebra known as norms, specifically L1 and L2 norms. But let me clarify something right at the beginning. We are not going to dive deep into the mathematical intuitions or proofs of these norms today. Instead, our focus is on understanding a core concept built upon these norms. Something that lies at the heart of how every AI model learns. So that concept of learning comes under regularization. Well, what is regularization? You have probably heard it said that the machine learns, right? But what does it mean actually? How does it learn? Is the model really learning something like human? In simple terms, learning in machine learning means adjusting numbers. That's it. That's what internally is happening. But adjusting what numbers? Specifically adjusting the weights that are tied to the inputs. So what it happens is when there is a weight associated or tied to the input, you set priority high or low. If you give the weights high, that input is of high priority. If the weight is low or zero, which means that input has low priority or no priority at all. So when we train a model, we hope it performs well. Maybe it gives 100% accuracy, assume. But often in real life scenario, we only get 80%, say for example, or even less. So naturally we ask, how can we improve this? So we want to adjust something, right? We want to adjust some internal setting. So what internal settings are we prone to adjust? Adjusting what gives you accuracy? So the answer is weights. So to make the model smarter for 100% accuracy or approximately 100% accuracy. And that process of adjusting the weights systematically with strategy is called regularization. So in this video guys, our goal is to show how machines learn through regularization using principle that originates from a linear algebra. Okay guys, now I have a question for you. What happens during learning? What is actually happening when the machine is learning? So that part we must be clear. So during training, a model receives data, input, makes prediction, and then checks how wrong these predictions are. So the input you give should be accurate for the result to be accurate. The difference between the prediction and the actual result is called the loss, right? Suppose if your model gives 80% accuracy, the loss is what? 20%, right? Because we are aiming for 100%. The model then updates to reduce this loss by adjusting the weights. But this update isn't random, right? You cannot update the weight just by tweaking the numbers. You cannot do that. You should have a strategy. It follows a logic, a strategy, and that strategy is governed by two important parameters. Listen guys, this is very, very important. So we know we are going to use regularization and we know that we are going to adjust the weight, but this adjusting the weight involves a strategy that is governed by two key parameters. Right? What are those two key parameters? One is learning rate, which is represented by eta, a Greek representation, and how big this learning rate tells you how big a step a model takes during the update, whether it takes a bigger step or a smaller step. So that is determined by the learning rate. Whether it is going to learn fast, bigger means what? Whether it is going to learn faster or it is going to learn slowly and gradually. So taking bigger steps has its own limitations and taking smaller steps has its own limitations, right? Second key parameter is regularization strength, which is represented using lambda. So what is this? What does this lambda has to say? It has to say how strongly we want to prevent the model from becoming too complex, or in other words you can say it reduces the overfitting. So together These two parameters form the basis of how models learn and stay generalizable without deviation or without overfitting. Okay, this is the theory part I have explained. Now I want you to take an analogy which I am going to tell you and relate these two parameters. What are those parameters? As I said, learning rate and regularization strength. To actually understand the in-depth intuition behind this, I would like to explain with an analogy. So let's imagine this as running on a track. You're trying to reach the final line, your goal. Okay, so you have a choice to take along faster rides or shorter control steps. You have two options, right? You can either take faster rides, or you can use smaller rides and reach the goal slower. Either you can use faster rides and reach the goal faster or quicker, or you can use shorter and control step, and at the same time you can reach the goal also. That choice, how big your step should be, whether it should be a faster stride or shorter one, this is called as the learning rate. Okay, now I'm picking up a higher rate, means faster rate, but what risk it involves? It involves overshooting, right? And on the second case, I'm picking a lower learning rate, that is slow and control steps. This is safer, but it comes with a risk of the model learning slower. Now imagine, okay, now that we have learned what is learning rate and whether we have to pick a faster one or slower one, it depends upon the parameters and various other reasons of picking this learning rate, right? Now imagine you're running fast and you start drifting off. We are going to explain the second key parameter, which is the lambda. So for that, I want you to imagine you're running fast. You have selected to run fast. Okay, I told you two options, right? One is learning high and one is learning low. So which means that you're basically learning high means what? You're taking faster strides, and learning low means you're taking smaller steps as per our analogy. Now to understand the second step, second key parameter, I want you to imagine you're running fast and you start drifting off the track. What happens is you start drifting off the track. You're moving but not in the right direction, right? That is where lambda comes in, the regularization strength. It's like guiding force that gently pulls you back onto the track. You want to be on the track. You don't want to run aimlessly on any other track without knowing your goal. So we want to keep the run in the track focused, right? So in machine learning term, this prevents overfitting. It stops the model from memorizing every detail, which means off track means it's memorizing every detail of the training data and irrelevant ones. So basically the minimum priority ones are also being carried out as the input, tied to the input, and this all causes what? Overfitting. So the final formula, applying both this learning learning rate and this regularization strength, comes with this formula, wherein we are updating the new weight. How we are updating? So what we are doing is weighted correction, right? What we are doing is you're correcting the weight. So we are reducing the error, but at the same time we are applying pressure to keep things clean, simple and general. This is a process that every neural network, every regression model and even large language models like GPT use during trainings. So what is next? So now that you have understand how models learn, use regularization, so our next video might dive into the difference between L1 and L2 regularization and show visually how each one treats weights differently. But so stay tuned, because how we trim and shrink weight is what gives the power to modern AI. But at this end of the video, you should be, I want you to stress that regularization comes in aid for laws, for calculating, for optimizing the algorithms, and even in natural language processes in many genres, this regularization is in play. Okay, so I hope this video has given you some inputs about how the machine or how the AI model is basically learning. Thank you guys. This is Lakshmi from the Sciverse Infinity.